try to record what we have here. So last week, Friday, I was able to grade your works, and as earlier, as I said earlier, our mission is to see, our goal is to see 0 missing homework, but still, we still saw some, a lot of missing homework in the course of grading your homework and assessment this Saturday and Sunday. So please, if you still have any missing thing, kindly go back and fix them. Or it's not only by fixing them, it's also by fixing them and letting me know what you fixed. Because it's always difficult to, to go into assign, each homework since the beginning, to be looking at those that did and those that did not do, because it's a long process, a long spreadsheet to verify names and class. So just let me know. Once you let me know, I'll just go to that particular date and then say, okay, Jayla says she did January 15 homework. Okay, let me open that link. I open, okay, I see her name, and then I put the grade. Not just trying to guess who has done and who has not done since January till date. I won't be able to finish. So please kindly help me do that. Once you do something, just let me know in advance so that I can quickly put the grade for you. It's not going to take me time, just a matter of seconds, I'm done with that. Welcome, Giovara. Okay, so as you can recall, last week, when we're trying to calculate the length of this particular arc here, which is the whole of this dark one, we use the formula that says L equals to 2 pi r times x naught over 360. And then here, r is the distance from the circle, from any part of the circle to the center, so which is the radius. So here the radius being 10, and then the x is the angle measure around the particular arc length that has been chosen. So here we have 240 divided by 360. Then if we use our decimals calculator, 2 times pi times 10, then times 240 divided by 360. That gives us 41.88, so approximately 41.9. So that's going to be L equals to 41.9. And since the unit is in centimeters, so we're going to put it in centimeter like that. But today, the new thing to learn is that for the area, for the arc length of a circle, we usually take part of the circumference. So here too, we're going to do the same thing by calculating the sector of a circle. So the sector of a circle is just a part of the area of the entire circle. So it's the part of the area of the entire circle. We're gonna see everything when we start doing the exercises, okay? So there's a special formula for that, which is, since this yellow part is what we're gonna calculate the area, okay? So the area here, oh, what am I doing here? That's messing up my page. Okay, then we go. So area is area of a sector. That will be, above here we use 2 pi r, which is this 2 pi stands for circumference. So in terms of area, you're gonna use, formula for area is pi r squared, and then also the x naught over x over 360. So the x naught over 360 is the ratio of the area we want to calculate over the entire circle. So it's like part over the whole, okay? So it stands for, what is all this thing coming on my page today? That's my offense. Okay. The area of a sector is found by multiplying the whole area of the circle by the part of the area that is, as we're trying to measure here, or we're trying to find. So this particular statement stands for x naught over 360. The 360 is the entire circle, and the x is just the yellow part. Okay, so the yellow part is a portion of the entire circle. That's why we have x naught over 360. And the area is of the circle itself is pi r squared. Then if we go into calculation, what is the radius of this circle here, Savannah? The radius, 13 inches. Okay, and then what is the x naught? The angle formed through us, the arc here is to 270. Okay, so here area gonna be pi r squared times x naught over 360. And pi is what we know it to be. R here is 13, but you need to square it and then multiply. Your x naught is 270, then divide by 360. And since the answer said do it in pi form, so it means you only need to calculate these guys. Okay, leave pi by the side. So I'm gonna use my decimal calculator guy again. Pi is isolated, so you're gonna do 13 squared times 270 divided by 360. That gives us 126.75. So you go back 126.75. And since the unit is in inches, like Sarah said before, or no, Savannah, so we're gonna have it in inches. So, here is just to invert the position of numbers and letters. It's like when you write x3, x times 3 is the same as what? 3 times x. In multiplication, multiplication is commutative, which means you can change the position of numbers, okay, or items under multiplication. 3x and x3 are the same, okay? It's like when you do 2 times 3, that gives you 6, and 3 times 2, which also gives you 6. So here we say they are commutative because you can change the position of numbers under multiplication, okay? But subtraction is not commutative because if you change the position of numbers under subtraction, you can lose the actual meaning of what you want to do. Like if you do 3 minus 2, that gives you what? 1. But if you do 2 minus 3, that gives you minus 1. And these two numbers are not the same. So subtraction is not commutative. Addition is also commutative because if you do 2 plus 3, 5, and 5 plus 2, 5. So you can invert or you can change the position of numbers under multiplication and addition, okay? Division is also not done because if you divide, you change the position, it's going to change entirely. 3 over 2 will be, a number that will be greater than 1, but 2 over 3 will be a number that will be less than 0. Less than 1 rather. So here, so it's possible then to invert the position. So make 126.75 come front and then pi goes behind. Then to round it up, just multiply that same value by pi. So if I put pi by the side, it's gonna give me an entire number, 3.98.18, so 0.196. So I'm gonna take one digit after the decimal point, so it's gonna be 0.2. So here, 398.2 inches. On the other side, Let me clean what I've done here before. What is the radius of this circle on the other side? Avalon, what is R here?
15.
Okay. This is R. And what is X naught?
60.
Oh, okay. And then we want to find the area of this place. And we know area to be pi times the radius square times X naught over 360. So you're going to be pi R square. R is 15. You square it. And then she said X to be 60 and then over 360. So this is the guy we're multiplying to be able to get the answer in pi, okay? So let's go to decimals again. She said 15 squared times 60 over 360. That gives us 37.5. So here, oh, where am I? So here we had 37.5. Pi goes at the back because multiplication is commutative. And then the unit here, don't forget, is in km, kilometer. Then the last thing to do, since they're asking us to round the answer, so we're gonna multiply by putting the exact value of pi, which, by typing pi here, it gives us 117.80. So 0 can go, and it will be, the 8 will be left as 1.1 number, one digit after the decimal point. Okay, so here we're gonna have 117.8 kilometers. And I'm sorry for the area, the unit is always in unit squared, okay? So here, this is gonna be in inches squared, inch squared, inch squared. And here, kilometer squared, okay? For area, it's always in unit squared, but the arc length is always in unit itself, okay? That's the difference, because here, the radius has been multiplied twice. So 15 kilometers times 15 kilometers, that's gonna be 15 times 15, kilometer times kilometer, and kilometer is being repeated twice, that's gonna be kilometer squared, okay? Because 15 repeated itself twice, that's why we had 15 squared. So your unit has to be squared as well. Then the last one looks like something we've done before. So here we have 2 ways of dealing with this. What is the total circle, the total degree around a circle? Savannah, you have an idea? The total degree around a circle. There's a big number we said. When you want to measure the total angle around a circle, what does it measure? Does someone have an idea? The total circle around this, the total degree around this circle.
360.
Oh, okay, so 360. And then since this guy is divided into equal pieces, okay, so how many pieces do we have here? How many pieces, class?
6.
6.
6.
So, okay, so you're gonna divide this by 6. And what is 360 divided by 6?
60.
60, okay. So it means each of these colors here will have a, a 60-degree angle towards the center. Now we are being asked to find the orange, the area of the orange and yellow. So it means these two guys. This is the area we want to find. So this is how, how many colors did we take here? 2 of them. So if each of them measures 60 and then we took only 2, so you're going to do 60 times 2 to be 120. So that means the angle that is formed in between them shall be 120, which means area being pi r squared times x over 360. X here is 120. And what is half? Here we know that from one point of the circle to another passing through the center is the diameter. And then we know that radius is always what? Half of diameter. So what is half of 34? Jovara, what is half of 34? Yes. If they give you a night $34 and they said we should share it into equal parts, so how much do you think you're gonna get? 17. Because most of the time, you know, people tend to calculate things fastly when it comes to money. That's why it's better to put all those calculations into money. So here 17 centimeters. So if R is 17, so since the unit is in centimeters, so finding the area gonna be in centimeters squared, okay? So here pi is the known guy. R here 17 is squared, and then X here is 120 over 360 centimeter squared. Let's go back to our, so 17 squared times 120 over 360. That gives us 96.3, approximately 96.3 pi. So this gives us 96.3 pi centimeters squared. Or if you put pi, if you put the value of pi, that's going to be 302.6 approximately, okay? So, or 302.6 centimeters. This. So the next thing to do is by using logic to solve the problem. Instead of taking 120 over 360, you can just take the ratio of the parts you want to find the area over the total subdivisions you have here. So here, we're going to say, you're going to take x over 360 to be equals to. So here, since we have 6 different colors, and out of the 6, how many did we take? How many are we using out of 6? Savannah, how many colors are we using out of 6? 2, okay. So we're gonna take this. So we're gonna say pi times r squared times 2 out of 6. And then that will be pi, r is 17, you square it, and then 2 over 6. Put this in your decimals to find whatever you have. So here, 17 squared times 2 out of 6 will be the same 96. $96.3. So it's the same thing as what we've calculated above before. So it'll be 96.3 pi centimeters squared. And if you put pi by the side to multiply it, that's going to be the same value as above here. As you can see, there's no difference between these two components here. So 302.6 as well. So here to take home, the best thing to do, if it's the arc length, always do take 2 pi r, find your radius, and then find the angle around where you want to find the arc in the arc length, okay? And then you do 2 pi r times x over 360. That is 2 times pi times the radius of the circle times the angle around the portion you want to find the arc divided by 360. But when it comes to the area of a sector, just use the the area times the angle of the sector you want to find, the area divided by 360, which means pi r squared times x over 360, where r represents the radius, and then the x represents the angle of the sector you want to find the area. So here, after that, you're going to see the GeoGebra animation here. As you can see, the blue side here is the side we want to find the area, is a sector. The blue part of the circle here is the sector, okay? And then we want to find the area. R here measures 3, and the angle around the sector is 50. So area being pi r squared over, instead of x in our node there, they use theta over 360, okay? And then by doing that, since theta is 50, r is 3, the square r, and then r squared times pi times 50 over 360 gonna give them this. And u means units and then the square. If it's in kilometer, it's gonna be kilometer squared. If it's in inch, it's gonna be inches square, okay? If it is in centimeter, it's gonna be centimeter square. That's, if it's in feet, it's gonna be feet square. So if I change r to anything, let me see. When I change r to 2.7, as you can see, the area changes as well. If I change the angle to 100, as you can see, the area definitely changes, okay? Let me increase the angle. You're gonna see how the area gonna increase. As the angle increases, the area also increases. See, from 15, when the angle is 239, if I go to 300, you're gonna see the area becoming bigger. And in terms of the radius as well, as the radius changes to, definitely the angle, the area gonna also change. So everything depends on whatever you're given. But the basic thing to know is make sure you know the formulas for arc length and the area, and then know how to get your radius. Sometimes the radius is given, and when it's not given, look at the diameter. When the diameter is given, just divide it by 2 to find the area. And then find the angle that is formed around the sector or the arc length. Okay, then take that ratio to multiply by the circumference in the case of arc length, or by the area in the case of area of the sector. That's all we have for ourselves today. Then we're gonna just quickly go and see what is there for us in the homework and then call it a day.